Hello. Hi, everyone. Great to be here. I forgot how amazing it is to speak in these big theaters. A bit nerve-wracking, but amazing. And I'm here to talk about a tool that I'm building called Digma. And in the course of this talk, we'll talk a little bit about performance issues, a little bit about OpenTelemetry, and something called continuous feedback. And I hope I'll explain a little bit of why I think it's a good idea to use all of these things and what we're trying to build. So just a few words about me. I have definitely kind of a split personality between being a product manager and a developer. Could never quite decide what was the right thing for me. As a developer, I always wondered about like, what's the use case, who's the user? So they kind of got tired of the questions and they told me go be a PM. I did that for a while, but they forgot to revoke my source code privileges. So eventually, I continued coding stuff, and then they went, go be a developer again, and I kind of gravitated between the two. And I think this tool, as well as this effort and project and everything that and this talk has been driven, much like other things, by frustration. And so before I start, just maybe a quick show of hands. How many in the crowd are currently using observability? Quite a lot. Amazing. Now, here are kind of the stages of very high level of the release cycle, from coding to test and debugging to CI and production. Now, it could be that I'm wrong, but how many people here use observability in production? Okay, most of the people. How many people here use observability in code and in test and debug? Okay, there is one person that I'll probably want to talk to later. But this is a problem. Because, see, I've been doing the same thing. And eventually, I came to the conclusion that I've actually developed another job, which is I'm an archaeologist. Because I was waiting for a problem to occur in production, and then I started going through the logs and traces, and I dug this very specific metric or trace that pinpointed a very specific problem that happened, and I was very happy. And I felt like a hero because I saved the day, and everything was amazing, except for one fact that I kind of managed to suppress, which is that find, that log, that metric was kind of there all along, right? It's true that I found it and I dug it up and I was able to root cause analyze the problem when it already occurred. But what's the trick here? Like that piece of information was not hidden in any way and form, except that it was maybe hidden by the fact that there were so many other irrelevant pieces of information that was impossible to notice. And the only way to notice it was when an issue occurred. Now, this was kind of funny to me. I learned about it. Maybe you guys know about it already, but I learned about it a while ago that the first subway carts were actually windowless. And there was a good reason for that. Like, why would somebody need a window that's looking at nowhere? Like, well, what do you see there? Like, it's basically dark, right? But people got terrified, and justifiably so, riding in these carts where they could not see what was going on. It was like a box. And they grew a little bit claustrophobic, so they added these, what could very well be pictures of a window, because it doesn't show you much, and eventually people got feeling much safer going on the subway. And the equivalent here is that if we don't have a view about what's happening, what's going on with the code, we're essentially waiting for the subway train wreck to then analyze why it derailed and what was the obstacle that the cart bumped into. And this didn't make sense at all. Not only did it not make sense at all, it was kind of against everything I knew about the kind of DevOps loop. And this is, by the way, the slide that proves that I didn't make up the term continuous feedback, but also just the first Google Images slide that will pop up if you search for the DevOps loop. And what you see here is that it's actually meant to be a part of the process, not have a problem, go look at the logs, but you're supposed to get feedback all of the time. And if that feedback was amazing and effective and easy to use, then you wouldn't need to wait for a problem. Something out there would analyze the logs and traces and metrics and tell you, hey, you're going to have a problem. And you know what? It doesn't need to happen in production. It can find those problems in CI, in staging, in other environments. But nobody's looking, right? And it seems to me like there's a big confusion when we talk about observability. And I think a lot of the existing toolings, like many of the APMs, sin in that way. And a lot of the kind of projects that I've seen around observability are kind of focused on that way as well, maybe because observability comes from monitoring. I visited the offices of a very kind of big company in Israel, where the engineering manager was actually kind of showing me around, and I saw these huge LCD screens showing amazing dashboards from observability, and I thought, I have so much to learn from these guys. These guys nailed it. Then I talked to the engineering lead, and I told him as much, and he said, you know what, I'm kind of embarrassed to tell you, but I just had a review meeting with one of my employees, and he just said he always assumed they were screenshots. And the problem is that often they may have well been, right? If you have a dashboard, and maybe it's red, maybe it's green, maybe it's flaky, maybe you change the threshold, it's not conducive to creating a proactive rather than a reactive process where you can actually use that feedback efficiently. And here is where the light bulb kind of turned on for me, because I said, wait. There is, on the one hand, a lot of valuable data. I know it for sure. Why do I know it for sure? Because each and every time there was a problem, I was able to trace it down to the specific log trace metrics and so on. So the data is there. But on the other hand, here we are, and we're not using that data. And that is an information problem. And information problems are something that we're good at today, much more than previously. We have a lot of means and experience in solving information problems. And that's why I thought, here is a problem that I can solve. And everything I'm going to show you today is free for developers. It's something you can use right away, and it doesn't require any effort. And I'll show that in a sec. But I claimed that there is valuable data in observability. Where is the proof? Like, what kind of data am I talking about? So all of you are running applications. You have, you're developing code. It sounds like many of you are collecting data about it. How can we actually use it? Like, not show dashboards, find ways to make our code better. And I'm going to give a few examples and illustrate how we've solved that problem with Digma. And I have to say, we've just automated a lot of things. We've automated a lot of processes that I could do on my own. The only reason that it's not happening is it takes time. And who has time? It takes expertise, because who wants to freshen up on statistics 101, remove outliers, run regressions, and understand if it's a trend or just a flicker in the metrics? And it also context switches me, and that's a problem. So everything I'm going to show you is also integrated into existing toolings. It's not like a new dashboards, go check this out. This is in the IDE, in the CI, and so on. So let's start with something maybe more simple. Let's forget about all of these issues and start with something very mundane, very day-to-day, which is something many people take for granted, but it is still important not to break the code. And I have actually been in a very frustrating conversation with a team lead who told me, number one source for P1 issues for us is people overriding each other's code because they're using shared modules or whatnot. So every week I have, okay, this other team changed subtly the behavior of this function, and suddenly I have a P1 issue because this other team was relying on it, and so on and so forth. So how can we actually prevent that? So this information, or the information about who's using this code, is something that is available in observability, even if it is not in my repo, even if it is not in my project, even if it is not in the specific code that I'm debugging. Somewhere in my observability, I have record of the fact that other people are using my code. So let's see how a different flow would look like. And this is even before we start talking about how we spot issues. So let me share my screen for a sec, because too many slides. OK. I'll make this a little bigger. Perfect. So I'm going to make a code change. Very simple. So I have this great project that I've written that is way too complicated, but that's what it's supposed to illustrate. And I'm going to start by making a very simple fix to a very common problem. So I'm going to go into a common module, and I'm going to look at a specific hashing function. And I'm going to do the number one fix for code synchronization issues. You're right, it should be 200. Got it. Perfect. So here is the updated code. And I'm feeling very confident because this is my code. And what I'm going to do now is just, let's create a branch. And let's push it. Perfect. And now let's go look at my pull request. And what would happen now is all of my tests would run, and my integration tests would run, and everything would kind of, I'm doing everything by the rule, and somebody's even going to do a code review, and maybe it's a developer from my team, and he knows my repository, and he knows my project, but he knows nothing about the other things that's going on. And all we have to do in order to make this slightly better is to look up who is actually using my code if I look at the observability. And whoa, we see a new comment here. And in this new comment, we can actually see we have what are the impacted flows. And we can see it's coming from the contract service. We'll see it in a sec. Processing, going into the shipping started. And I can actually see what is that usage is, what I changed. And if I click on it, I can actually see the trace and the class that I just changed. So it's very easy for me to see how that specific service, in this case the contract API, is using the code that I changed. And this is the difference between taking this same data and putting it on a dashboard where nobody can actually use it and finding a practical usage for it. But this was a very simple example, how we can actually maybe be a little smarter when we make our changes. Let's take a look at the more interesting things. So I've been working on my code. There's obviously issues there, but I'm probably going to meet them next time there is an outage in production, or next time somebody or some APM identifies it, and then I need to go and understand why the cart derailed. So let's take a look at something a little different. So first, let me share a problem with you. So the tool and the methods that I'm going to show you, I've actually applied them at various organizations. And they revealed a lot of issues. So for example, let me kind of see a high-level view. I'm going to open my IntelliJ here, and I'm going to open my plugin, and let's take a look at some metrics. So this is kind of a high-level views of all of the issues that Digma, which is the tool that I'm showing you right now, identified. Digma is an IntelliJ plugin and a backend that runs on Docker locally that just analyzes the observability data and finds all of these things. And in this case, Digma has been looking at my microservices, and it found that order processing is actually a pretty hot spot in terms of issues. Then I have order shipping, and then all of the others are in the green. And here's the problem. So I went to one of the companies that we worked with on this, and I showed them the result. And they said, amazing, you're right. Order processing, in this case, is the service that is a terrible service, legacy code. We've been carrying it for 3 years. I said, great, what are you going to do about it? Well, then, nothing, because we've been carrying it for 3 years. Who cares, right? But then I told them, what if I could tell you what changed in the recent sprint or in the recent release? Sure, you don't care about the things that already happened, but if you could catch something new early, you could close the feedback loop earlier. Instead of trying to dig into this bug 3 months from now, you can just solve it now, especially if it's a very low-effort bug. So they said, amazing, show us how you do that. So we can look at changes. And in this case, it's kind of similar because I was just running this example before. But this is where I can see which service actually had the most changes, in this case, looking at the past 7 days. And I can see that there are 3 new issues around order processing that are a result of the code that went into the code base this week. And this is more interesting, because now I, as a team lead, can say, OK, that's interesting. What are these issues that you're telling me about? And I can click, and I can see, OK, these are the issues I have. And they're ordered by priority, so we can use the data from observability to see what matters and what doesn't. How much time does it take? How many services does it impact? How much usage do we see if it's a production environment? If it's a staging environment, how much wide is the reach? How severe is the problem? In this case, we have a suspected N+1. Is it an N+1 of 1 or 100? Like, what are we talking about here? And I can go into this specific issue that we identified. And these would be bottlenecks. These would be performance degradations. It could be a lot of things. All of them, by the way, are using OpenTelemetry, and we'll talk about it in a sec. And now that we have the data, and there is a lot of ways that I can kind of continue and drill into the data and understand more about the flows, but that's not important. I can open a ticket if I want somebody to actually fix it. And one thing that's really cool about the ticket is that I can see the commit in which it was first detected. So to make the data from useless equals dashboard, or I have to share this with you because I had to go through it today. These are my application logs, and I'm really trying to make sense of them. And this is a live example. There are issues just as important here, but they're almost impossible to find if I don't spend a lot of effort. And here is kind of the result of that. So we kind of invert the pyramid. We start from the result. Now we can go look at some examples. So the problem is there is an N+1 select. These are the affected endpoints, and this is where it started. So I can go click on the commit, see what I've actually checked in there, and identify that this is the problem. If I want to see, as a developer, I get handed this. I now want to see more information. I can click on a trace and see, OK, what does this problem look like? Is this really an N+1? And yeah, this definitely looks like an N+1, right? But I have the context now. So I'm not fishing around in gazillions of logs and traces and metrics for problems. I start with the problem, and now I can see an example that will illustrate to me how it came about. Now, the amazing thing is that to use this, and I use this regularly when I develop, but you can run it on CI, on production, on staging. You can actually also compare the environments. There's a lot of information to gain there. But to get started, all I need to do is not enable OpenTelemetry in my code, which is like the standard way to collect data, is not to add anything to my code base. I just need to install a plugin and run my app. So I'm just going to rerun it to show you. And what the plugin is going to do as I run it is just going to add, I can choose if I want to use Micrometer, or if I want to use, in this case, it's just using the OTEL agent. And it's going to go on and download and configure it for me. So if I want to see if there is useful data, even starting from my local environment, I just install a plugin and run my code. That's it. And this was critical because I knew that if it became an item on the backlog for the team to prioritize, hey, we need to take care of observability, hey, we need to add this to the CI, it's just going to get prolonged and kind of delayed because there's always urgent stuff. So the point is something you can do right now. Let's go back to the presentation. Cool. So we talked about not breaking the code, definitely understanding the state of the release. So what you saw in the heat map before was actually how we can determine whether our release is stable or unstable. When to hit the gas and when to hit the brakes is, for me, as a tech lead, as a team lead, as a developer often, a very important consideration to know whether I've actually reached that point where I've caused some destabilization. I can wait for kind of the Jenga tower to topple, or I can start detecting those issues early and then understand the problems before they occur. So not wait for the issue to happen, but to actually have something automated. And how we're doing this behind the scene, by the way, is we're collecting OpenTelemetry. Amazing. By the way, OpenTelemetry is absolutely not exciting. That's why I'm not talking about it that much. It's kind of like discussing something that I don't think developers that don't actually deal with OpenTelemetry should know that much about how it works. Just like, it's not like you need to understand SSL in order to use SSL. It's a spec. But the important thing is that it's open. It is agreed upon, which has never happened. And more important, it's supported out of the box by almost every single library you're using today. So when I do this magic of enabling OpenTelemetry via the plugin, all I'm saying is turn it on, turn it on, turn it on to all of the libraries, and that's it. And you get a lot of data. So here are some key takeaways. First, in terms of the way that I've chosen to implement it, no code changes necessary, and it is an IntelliJ plugin in the marketplace, which is free, and it runs locally. So nobody's stealing data. Nobody's going to look at the observability data. This is, by the way, why we had to restrain some of what we do when you run it locally, because early tests showed that when we ran a lot of models and regressions all the time, we kind of burn through your laptop battery within a ridiculous amount of time. So we decided, no, we're going to minimize resource usage, and it's actually not taking almost any resources when you run it locally. But you can also deploy it as a Helm file and kind of get all of the rich set of features. And we want to find issues earlier. We want to analyze the code change impact, and we want to make sure that we take care of release stability. I want to talk about another use case, which is how we can actually use this to scale a system. So instead of waiting for a problem, let's say I know I'm going to have more traffic. How do I prepare to scale? But before I do that, I want to give, if there is any question, I'd love to take it. Yes?
So you said that you're listening to the traces in the OpenTelemetry and stuff from prod. Like, how? How do you get that from production, which is normally an isolated environment, into something that, which is on your laptop?
Perfect. So there are 3 ways or 2 ways to run Digma. The first is if I run it locally on my laptop. And the reason to do that is why not? And it can find a lot of issues. From my experience, up to 20 or 30% of the issues are actually detectable in your laptop. We do a lot of tricks for that. If you run something concurrently, we kind of try to extrapolate from that how it would scale with more concurrency. If we see an inefficient allocation, we kind of try to speculate how it would happen in production when there is more of it. And even more important, if you stopped your IDE in a breakpoint in debug and went out for a lunch break, we're not going to tell you that you've just had a major performance regression. We know to detect it. So the idea is, how can we give something right away? If you also want to connect other environments, then definitely you'll want to install it in your org. This is where Digma comes to play as more of as an org solution. We deploy as a Helm file, so you can deploy it into any Kubernetes cluster very easily. And then it's just an OTEL receiver. So you send OTEL data. You can set it up in the same easy way that we do it in the IDE, which is basically adding a few command lines to your script that deploys the application. Perfect. Yes. If you have a central Digma, everybody can connect to the same Digma and even share the different issues that you find. Okay, now very quickly about analysis and scaling. So we use Digma a lot, and we said, OK, let's try to use Digma to find the most slow things that we have and fix them. And somebody mentioned to me this brilliant strategy. He told me, I think it would be a great idea every week to pick the 5 slowest thing, let's say 5 slowest queries, and fix them. And then, for sure, within 2 months, we'll have a much faster system. And we did that for 3 weeks. And can anybody guess by how much it actually moved the needle? Give me a number between 1 and 10. That's right. Absolutely nothing. And the reason, and we were very proud of ourselves, and it didn't do anything. And the reason is that to understand what actually improves your scalability, you need to look at beyond simple metrics of slowness and duration. You need to look at how it impacts the system. Okay, I might have a query that takes 200 milliseconds, but it's a part of a 10-minute background job. I might have a query that is horrendous, but it's only called at startup. I might have something that I think is the most important thing in the world, but it's actually non-blocking and asynchronous versus something that many other queue events depend on. And to do that, you need to do, again, it's an information problem. I love information problems. If somebody comes to me with a product problem, I fumble. But if somebody comes with an information problem, it's either solvable or not. And in this case, very solvable. Because we have the technology. We can look at how the system behaves when it's fast, how the system behaves when it's slow. We can correlate different variables. How does it work when you run it once? How does it work when you run it concurrently? Create a graph, start analyzing it. And based on that, understand the impact. So when I look at Digma, And let me, again, change to mirroring. Um, yes. So I can actually see all of the assets that Digma has detected. So this is basically a lot of endpoints, consumers, some internal operations, database queries, caching would go in here, all sorts of categories that we start working on and crunching. And in fact, everything Digma does is create these or start following these code locations, these different places, and seeing how they behave over time. But what I can then do is I can take any category, code location, database queries, it doesn't matter what, and I can sort it by performance impact. And this is something new. So if I can sort by performance impact, this gives me a very different list. This now gives me a list of the 5 most performance impacting queries in my system, or 5 most performance impacting code locations in my system. And then we tried optimizing that. And this made a difference. Not right away, because we had to get to the right formula, what we want to factor into impact, how do we adjust for artifacts. But once you do that, you can get to a very finite and clear list about here are the things that happen that matter the most. And the same, by the way, logic we use for any issues that we found. So when I created the code to detect any type of issue, let's say I have here some code locations. Let's take a look at this. So here we have a specific bottleneck that we identified in the system. To understand that this bottleneck is severe, I had to understand a lot of things about how it impacts the system when in different situations. And I had to get rid of a lot of noise. But the important thing is that the result is having a very simple list to look at versus a huge list of 1,000 issues that would effectively be micro-optimization. Because I think about half a year ago, we found that the biggest problem is if you actually succeed too much. And not that I'm saying that people are writing bad code. It's just that every code has things that are bad or good. It's sometimes not that important. So we would run it in a specific location, and the customer would be horrified to see that they had like 200 issues. And then they said, this is useless. What can I do with 200 issues? I can't even start working with that. But if you prioritize them, if you understand their criticality and effect, again, you turn a dashboard into something useful, something that's workable, something that can be translated into work that people do. So to conclude, and then if somebody wants to ask additional questions, I'll be very happy to answer. For me, the idea is how to translate knowledge, which is too much data, into understanding. Things that are actionable, that improve our understanding of the code. And this is what we're trying to do with Digma. Now, I did create, I know we didn't have time to go into a lot of details about OTEL and observability and the rest. So I did create a Udemy course. This is a coupon where it doesn't cost anything. So if you want to get it with no money, you can just get that coupon. It's just a Udemy course that explains some of these processes and where I kind of go through what I've kind of shown here in brief. And with that, anybody has any additional questions? Otherwise, we're very short on time. Yeah? Yeah, go ahead. Can you use tests to generate data? Absolutely, you should. And there's this whole other thing. I would actually recommend using integration tests because they simulate a lot of behavior. I think it's a topic for a different conversation, a different talk that I could talk for hours about. But tests are untapped potential. They simulate behaviors in the system, and we are only looking at pass-fail, which is a very narrow perspective. Yes, amazing. And we see a lot of really important insights with tests. Perfect. Thanks, everybody. And if somebody has questions, please go forward.
All systems are nominal. Initialize Genesis